Right, good day class. We'll be looking at the addition or subtraction of rational expressions. Okay, but before we do that, we need to review the addition of common fractions. Okay, here we have a half plus 1/3. Yes. In order to add these two fractions, we need to create a common denominator. Okay. The first step we need to take is we need to find a common multiple of these two numbers. Any common multiple would work. Yes, but we are going to focus on finding the least common multiple, the smallest multiple of 2 and 3, the smallest number that 2 and 3 can divide into without leaving a remainder. Okay, and that number would be 6, right? That would be 6. Now we are going to transform the denominators to get 6. Okay, so I'll be using multiplication to do so. So what am I going to multiply 3 by to get 6? It has to be 2, right? And to keep the value of this fraction, I need to multiply the top by 2 as well. All right. Now, what do I need to multiply 2 by to get 6? 3. Yes. Now, to keep the value of this fraction, I need to multiply the top by 3. Okay. All right. So now I have 3. 3 times 1 is 3, right? And 3 times 2 is 6. And 1 times 2 is 2. 3 times 2 is 6. And we are adding, yes? Now, when we have the same denominators and we are adding, we can keep the denominator, okay, which is 6, and add the numerators, okay, 3 plus 2. So our answer is, let me write it beside it, 5/6. All right. Now, because these two denominators are the same, we say that they are common denominators. Common denominators. Yes, very important. Also, to get a common denominator, I could have simply taken these two numbers and multiplied them to get a common denominator. A common denominator. Okay? I could have said from early the common denominator is 2 times 3, yes, which is 6. All right, all of this will make perfect sense when we look at an example of the addition or subtraction of rational expressions. All right, so here is an example. We have x minus 3 divided by x plus 5 minus 5x divided by x take away 2. Okay. Now, before I continue, I want to do something that is very important. Okay. My job is to make difficult topics simple. All right. I'm going to write a 1 here and a 1 here. All right. Now, what this means is I am subtracting one expression from one expression. Okay. Good. Now, before we continue, let us do the same thing that we did previously. Let us find a common denominator. Notice what I did here. I simply took these two numbers and multiplied them. Yes, and this would give me 6. Yes, this would give me 6, which would be my common denominator. Yes, so this has a value of 6. All right, the same principle we will be using here. All right, so common denominator. Okay, common denominator. All right, so all I'll be doing is, as I did in the previous example, I just say 2 times 3, and that would give me my common denominator. Okay, so I'm going to say my common denominator is x plus 5 times x take away 2, and I leave it like this. All I did, I took the denominators and wrote them being multiplied together. Yes. Now my next step is to make the denominators resemble what I have here. Yes. So to make this resemble 2 times 3, I wrote what? 3 times 2. All right. So I check to see what is here. A 2 times a 3 is here. All right. Here we only see a 2. So I need to multiply it with 3 so that it resembles what we have here. All right. I notice that this doesn't have a times 2, but this has a times 2. So I'm going to multiply 3 by 2, as you can see here. All right. And to maintain the value of each fraction, since I multiply by 2 here, I'm going to multiply the top by 2. Since I multiplied the bottom by 3, I'm going to do the same for the top as well. Okay, similar principle. All right. So let me rewrite what I have here first. All right. Rewrite what I have here first. All right. So notice my common denominator has x plus 5 times x take away 2. I only see x take away 2. So I need to write x times 5 so that my denominator resembles my common denominator, resembles this expression here. Okay. And since I'm multiplying the denominator by x plus 5, I need to do the same for the top as well. Okay. All right. On this side, there is a missing x take away 2. We want the denominator to resemble what we have here. Okay. So x take away 2 is missing. All right. Do the same right here for the top as well. All right. Okay. All right. Before I continue, notice I had a 1 here, but I no longer have a 1 here. And the reason is we know that anything times 1 is the same thing. All right. So I don't need to write 1 here again. All right. Because 1 times anything gives us the same thing. Yes. All right. Now, notice here we have a common denominator. All right. But in this case, we multiplied the denominators to give us 6 and 6. Yes. Yes. Now we have a common denominator again, and because of that, we keep it. Yes. And then we focus on working on the top. We can simply write what we have here, 3 and 2. But how we got the 3 and 2, we said what? 3 times 1 is 3, right? And 1 times 2 is 2, all right? So we are applying the same principle as we go along, all right? So we have a common denominator. They are the same. And because of that, we keep it. So x take away 2 times x plus 5. All right. And then you're going to have at the top x take away 2 times x take away 3. All right. And we're going to have our minus 1 here. Minus 1 times 5x times x plus 5. All right. Then we continue working. All right. So x times x, that's x squared. X times negative 3, negative 3x. Negative 2 times x, that's negative 2x. Negative 2 times negative 3, that's positive 6, yes. Negative 1 times 5x, that's negative 5x, alright. We still have our x plus 5, alright. All over x take away 2 times x plus 5, okay. Alright. Alright, let me push this up some more. Alright. Let's continue working. Now we have two pairs of like terms here. Alright. So we have x squared. We combine our like terms to give us negative 5x plus 6. This is times now. We are multiplying these two now. Alright. So negative 5x. So all of this times x, that's a negative 5x squared. All of this times plus 5 gives me negative 25x. Alright. Alright. Now as you can see, we have some like terms we can combine. Alright. So those two would combine to give me negative 4x squared. And see, we have two more like terms. Alright. Those two would combine to give me negative 30x. And we have a constant term that is plus 6 all over x take away 2 times x plus 5. Alright. Now looking at my result here, I have a quadratic expression at the top. Looking at it, if I wanted to, I could factor out a negative 2 if I wanted to. Alright, but I'm not going to do that here. I'm just going to leave it as it is. And also looking at this quadratic expression, it doesn't seem to be factorable, meaning we cannot use the AC method on this one. Alright, so we're going to leave our answer as it is. Alright, good. Alright, now for my review of fractions, I added two common fractions. Yes. Now you may be wondering, why did I focus on subtracting two algebraic fractions instead of adding? The reason I did that is I wanted to do the most difficult problem, which is subtracting. Once you are able to subtract rational expressions, you can easily add rational expressions, and that's my reason for doing that. Okay, but I would advise you to re-watch this video until you understand what is happening here. Alright, so this is my answer: negative 4x squared minus 30x plus 6 over x minus 2 times x plus 5. Have a good day, class.